Good evening.
Yeah.
So when is the test?
Saturday.
Okay. So you want any difficult questions to discuss? And what is the portion?
From motion and plane complete chapter. From
Okay.
that and
And then
new laws of motion, Newton's first law, second law, and third law. Then law of conservation of momentum.
okay.
Till that they have taken.
This question we saw last time. Okay.
Yes.
You're able to see the screen?
Yeah, I can.
So the first one is the swimmer is going straight like this, according to this is the shortest path. Okay. So when it's going like this actually, with respect to the ground, it will look like this. Okay. So the actual path taken, okay. So the velocity triangle will look like this. Velocity of swimmer with respect to water. Okay. It will be like this. Plus the velocity of water. This is the triangle.
Yes, sir.
This one. This is the velocity of swimmer with respect to water. Okay. And this is velocity of water. Because water is flowing towards right. So these two should add me to get the velocity of the swimmer. Just like this. Velocity of swimmer with respect to water is velocity of swimmer minus velocity of water. The reference has to be subtracted. Vectors. Okay. So this can be understood as the relative velocity plus the velocity of water is the velocity of swimmer. Okay. So
Sir, can
velocity of
you like retake horizontal projectile motion, oblique projectile motion?
yeah, let me finish this one.
Yeah. Okay.
So is this clear?
Yes, sir.
Relative velocity is we have to subtract the reference. Here water is the reference. So this is the one. So this I can understand as the relative velocity plus the velocity of the reference. This velocity of water is velocity of swimmer. Okay. So the first one is like this. Second one is when it's coming back, the triangle, the velocity of the relative velocity will look like this. And velocity of water is here. And this is the velocity of the swimmer with respect to ground. Okay, so the time is the distance d by velocity of swimmer. And velocity of swimmer in terms of this relative velocity and velocity of water is square root of hypotenuse square minus the one side square. E to 2. Okay, so T1 is clear.
Yes, sir.
Okay.
I see. Yes.
Okay, so D would be the velocity of swimmer that I'm writing in terms of the relative velocity and then the velocity of water. Okay, in the second case, this is the time. Okay, while going along the water. See, one thing is the property of the swimmer is the velocity of the swimmer with respect to water because he's swimming in water, right? So if the swimmer has got a capacity of say some 5 units, okay, that 5 units is velocity of the swimmer with respect to the water because he's swimming in the water. Okay, that is fixed.
Yeah.
Okay, and
Yes,
then
sir.
one thing he can choose is his direction in which he can swim. So this is under the control of the swimmer. Okay, so in the first case, he's heading like this, but with respect to the ground, he'll go straight in the shortest path. Only if setting at an angle, this water will take him in this direction. So with respect to the ground, he'll appear as if he's going straight, shortest path. So while coming back,
Yeah.
he's heading in this direction. Okay, so then the relative velocity plus the velocity of water will give the velocity of swimmer in the shortest path. Second case is one is going along the water, so that time the time is d divided by the velocity of water. So with respect to water, plus the velocity of water will add to it. Okay, while coming back, it will subtract. It will oppose this speed. Okay, so this is T2. Okay, so T3, when the water is still, whatever is the distance, say 2d, divided by the velocity of swimmer with respect to water. Velocity of swimmer with respect to water is property of the swimmer, which is fixed in all the cases 1, 2, 1, 2, 3. Okay, so from equation 1 and 2, we have to eliminate the velocity of water because here relative velocity is there. So this is 1 and this is 2. Okay, so from this I'll get square root.
Yeah.
So this is the first one. So from this I'll get this thing, which is equal to, because velocity of water is here only, equal to this one. From here I'll get T2 by D equal to cross multiply twice the velocity of swim with respect to water, divided by the denominator, this one. So this one I can eliminate. Yeah, because in the numerator I have this velocity of swimmer. This is the one I have to find out. Property of the swimmer. Okay, so this thing I can write as, or I can here, uh, d by t on the whole square equal to d by what I have done here. Okay, this one. Okay, this thing I've used here. So this one I'm using it here. Okay, so this is the right hand side for this thing. Okay, I'm getting this thing from this one. So this one from here I'll get velocity of this square is equal to twice velocity of this thing divided into d by t2. So this I'm writing like this. Is that clear? I'm eliminating this whole thing.
Yes, sir.
Clear? The mic is off.
Yes, sir.
So from this I'll get the velocity of the swimmer with respect to water.
Yeah.
Okay. So from this I'll get okay. From this I can also radiate this T2 by T1 square as velocity swimmer by D. This is actually 1 by T3. T3 is 2D by velocity with respect to water. Because in this third case, the water is still, but still the time is distanced by the speed of the swim with respect to water. Because the property of the swimmer is this relative velocity. This is the important thing to realize. Swimmer is characterized by his speed with respect to the water and the direction he can choose. There is in this control.
Yeah.
So okay, from this I'll get this result. T3 is T1 square by T2. So option 3. Okay, I'll just send this notes to you, just revise it.
Okay, sir.
Okay, so what we said in the beginning, oblique projection.
Retaking oblique projection, horizontal projection.
On an inclined plane. Inclined plane is the last one, right?
Projectile motions.
Yeah. Projectile motion, the last cases. Okay, let me open this one.
Kinematic equations wise, I'm okay. I'm alright. I can do it. But like in three vectors, if they're given x-axis, y-axis, and z-axis with the missing variable, how to do that type of question, sir? Sir,
Now, wait.
with an unknown integer, if they're given x-axis, y-axis, and z-axis, how to do those type of sums?
Repeated?
Like in I cap, j cap, and k cap, if they're given an unknown integer, how to do that type of sums?
Give me an example question.
Like if u is equal to 2i cap plus minus 2j cap plus 3k cap, the final velocity is v equal to 2i cap minus 4j cap plus 5k cap, is covered in a time of 10 seconds, and find the acceleration vector.
Trivial question, no? U is given B. So V minus U by T.
In vectors, vector
Yeah.
addition and
So,
subtraction.
yeah, you have to do components, no?
Wait, I'll just do it.
I understood your question.
I cap cancel. J cap,
Just a minute. See, U is given as a vector. Okay. let me write as this meaning is 2i cap, 3k cap, 3j cap, 5k cap. Okay, and V is say 3, 6, 4. Okay, now to find the acceleration, the time is given. This happens in a time, say 5 seconds. So acceleration by definition is V minus U by the time interval. So do V minus it's 1, 3 minus 3 divided by 5, which is 1 by 5 I cap, 3 by 5 J cap, minus 3 by 5 K cap. But the important thing is this is average velocity, not instantaneous. Because the finite time interval, no, is average. It's average in this time interval for 5 seconds. Instantaneous means this small change in the velocity dv by the corresponding small change in time dt. So to find the velocity at time u plus delta v. That should be known. From these two, I'll get velocity acceleration instantaneous. If it is a finite time interval like this, then what I get is average. Is that clear?
Yes, sir.
So what's your doubt now?
So like if they give three vectors, x-axis, y-axis, and z-axis respectively, and like one is with like a natural number like c, one is some natural number into integer c, k cap. Then how to find the value of the integer c?
Sure, send a snap of the question.
So like this 2 cap plus 3 j
Can
cap
you send the snap?
3 c like that. Like if this they are given, how to find the value of the c integer? Sorry, is it visible? Wait, I'll just remove. Yes, it is visible now, sir. Sorry,
2 I
it's
cap, okay, plus 3c k cap, okay, fine.
how do you find the value of c?
So what is the complete question?
This is it, sir. Like they're asking to find the value of c.
No. What you showed is u or what?
This question I think they asked in the exam like last time. I'll just find it.
I need the complete question.
Yeah, I'll find it. I found it.
You already sent me that yesterday?
Over here, I think. Yeah, this one.
No, is it in
Can
the
you see, sir?
just a minute?
Visible, sir.
No, out of focus. No, you should take it outside. No, just bring it a little bit closer. Okay, you read out the question.
The position vector of a moving particle at t seconds is given by r vector equal to 3 I cap plus 4 t square j cap plus minus 3 t cube k cap.
Okay.
Is displacement during an interval of t equal to 1 seconds to t equal to 3 seconds is?
What is given is acceleration or velocity? Velocity.
R is given. Position vector only given.
Whatever is given
Position
as 3. R is given, huh? Okay, find R and this. Displacement between what time interval? Yeah, okay, I got it. Leave it.
Yeah.
So what they given is R. Okay. I cap, J cap, K cap. Some function of time. Okay. So you have to find the displacement, right? Displacement between which time? First 5 seconds. What is the question? Displacement?
R equal to 3I cap.
No, that's fine. Question is what? Displacement? Find
Yeah,
displacement.
displacement. Yeah, to find displacement. R
In
is
what
given.
time? In what time?
In t equal to 1 seconds to t equal to 3 seconds. From 1 second to 3 seconds.
Yeah. This is equal to R at 3 seconds minus R at 1 second.
Which
See,
is R into like the initial vector
see,
substitute
this is
3
the
minus
initial
the
point.
final.
This is the initial point. This is the final point. Okay. At the initial point, it is at 1 second. The final point is at 3 seconds. Okay. So this vector is known. R at 1 second. I just have to put 1 second in this given expression. And this is also known. R at 3 seconds. So this displacement is this one, which is final position vector minus the initial position vector. I have to reverse this, right? Then I have to apply the triangle now. So initial to final point, I can go like this. This one
Got
way.
answer as 32 j cap minus 26 k cap.
Okay, so this can go this second way like this.
Sir, like just a minute, I'll be back.
Minus R1 plus R3. That is R3 minus R1.
I'm back.
Yeah, so this is one way of going from the initial point to the final point. There is a displacement. Second way is 3 through minus R at 1 second. This is minus R1. Because
Yeah.
R1 is from here to here. R1 means R1 at 1, R at 1 second. So minus R1 plus RS. So this is the same as remembering like portion out to the final point minus the portion out to the initial point. So R at 3 seconds minus R at 1 second. Put t equal to 3 in the given expression and put t equal to 1 in the given R vector in terms of time and subtract them. Got the answer?
I got the answer. I
Check it.
got it as 32 j cap plus minus 26 k cap.
Check the answer.
Yeah, that's the answer. Fourth
Okay.
one. Because both R at 1 second minus R at the third, R at third second minus R at the 1 second.
Yeah.
Both I subtracted and I got obtained.
Yeah. Final position vector minus initial position vector.
Yes, sir. And yeah, that's one thing. Then, like this question, sir, a train moving at a constant velocity of 54 kilometers per hour moves eastward for 30 minutes, then due north with the same speed for 40 minutes. What is the average velocity of the train during this run in kilometers per hour? I'll send a snap of that question. Just a
Yeah.
minute.
Question number.
Question number 4 in this page.
You just have to draw a small figure.
So, like displacement, we have to find manually in this.
No, first you have to get the. No, what they are asking.
We are given time and initial velocity, final velocity we have to find.
Yeah, final position is initial position.
Yeah. So we have to find displacement.
Yeah.
They have given only one speed, so how to find the second speed?
No, speed is same. Direction is different. They are given the same speed. No.
Velocity, yes, same velocity. So we just take 30 by 54 and 40 by 54 to find displacement.
Because the train is moving towards east. Okay. Up to here. 54 kilometers per hour.
13.5 1.35.
30 minutes. After that, it is going in the north direction for 40 minutes. Use 40 minutes. Speed is same, 54 kilometers per hour. So in half an hour, it will come to the distance of 27 kilometers. The meaning of 54 kilometers per hour is you will travel distance of 54 kilometers
0.8.
in 1 hour. So 30 minutes is half an hour. Right? So in 40
Sir.
minutes, you will travel a distance of 4 by 6 into 54. 9 6 of 54. 3 will go 2 times. 3 will go 1, 24.
36.
So 9. 9 4 are 36. So the coordinate of this point is 27, 36.
36.
So this is the displacement.
Yeah.
27 I cap plus 36 J cap. Displacement is, I can also write this comma in terms of comma. Understood it is 27 I cap plus this J cap. Average velocity is the displacement by the time, which is 30 minutes is half an hour. Okay, totally 70 minutes. So 70 by 60 hours. Okay, it is 6 by 7. So 27 into 6 by 7, comma 36 into 6 by 7. Some decimal numbers are there given, right? Okay, fine. So 27 and 36, I can get the average and then multiply by. So it is actually, I have to find the magnitude of this 27 and 36. So 27 square plus 36 square. 9 is common. So let 9 square into 3 square, 9 plus 4 square. So 3 square plus 4 square is 5. So this is actually 5 square. So 9 into 5 square. So it's 45.
45 square.
45
Which is 2025.
45 into 6 by 7. So less than 45. So this has to be this one. So that you can check 7 6 of 42.
38.6, I think so. Is it the answer?
So this I can write as 7 6 of 42. So 36. The remaining is 3 by 7.
That's 38.6.
3 by 7 into 6. So 18 by 7 to 2. Yeah. 2 point something. So to draw this figure, that's the first step and the important step.
Yeah.
To understand what is going on. Okay.
Yes, sir.
So the final coordinate is 37, 27, 36. Displacement is
27. The 27, it came from like the 54 by 30 minutes.
this
54 by 0.5 is, right? 54 into 0.5, right, sir?
Yeah.
So same way this also 54 minus 54 into 3 by 4, I think so. Is it right?
Okay. Any other question?
I think so. That's it. Then below that, this thing, sixth one.
This is minus, I think. 3t, 2t square, and then this is some mistake is there. It's minus. Okay, about plus. Okay. Straight question. Just differentiate this one. Okay. So this thing, if I differentiate twice, it will become 0. So y component is not there. So k component is not there. So it does not matter. Plus or minus. So this one, if I want to differentiate once, I'll get 3. Okay. So option 1 is gone. And then if I different acceleration should be 0 because acceleration, yeah, only the j component will come. So the acceleration is -4. In 3 options are there. So the acceleration, the velocity is 3. Velocity is 3. 3 and then velocity is 3 and this one is -4. The first one. Velocity is function of time, the y component. Option 1. And acceleration is dv by dt -4. Actually, the option 1 with the minus sign here. There's a mistake in the question. What is the given answer?
The answer it is given as sixth one. It's option 4.
The t is missing here. This should be -4t. Okay.
Equal to -4j cap.
Here it should be t because velocity is differentiate once. No, so if you differentiate t square, we get t. So here there should be a t here. Okay.
And eighth one. Sir, if they're given a y coordinate and like is equal to some x coordinate, then how to find the acceleration of that coordinate?
Wait, what is? No, it's question number which one?
Eighth
Which
one.
question? Which question?
Seventh one, seventh question. So like they've given y coordinate is equal to x coordinate, and like velocity has value of 1/3. Now they're asking acceleration. How to find that acceleration?
Acceleration is
Sir,
velocity in the. Okay, find. Okay, differentiate both the sides. T by dt is 9. Okay, I can just try. Okay, differentiate y equal to 9x square. No. So differentiate both the sides. You get vy equal to. Y equal to 9x square. So just differentiate both the sides. You'll get dy by dt. dy by dt is nothing but vy. So vy equal to
d by dt of 9x square.
18x into vx. Correct? No.
Y is equal to 18x t.
And this vx is constant, which is
Oh yeah,
1/3.
velocity. Yeah, v is equal to x.
1/3. Okay, so
1/3 of 18 is
ay, differentiate this thing again. 18 into this one is again vx 1/3. Again, this is 1/3. So this is 9. So this 2 ay. Ax is 0. Why is Ax 0?
Six. Sir, shouldn't it be six? Okay, two is.
Ay knows it's
X should
around
be
0.
Ay is
Ay.
constant, so X should be zero.
Vx is constant. They given in the question. X component of
Yeah.
velocity remains constant.
Okay, I had that. Yeah, that's a zero.
X component velocity constant. That means d by dt of Vx is 0. So from here to here, I'm differentiating again with respect to time. So Vy, if I differentiate, I get Ay. X, if I differentiate, I get Vx. Okay, there's a constant, 1/3. Okay, and to get Ax, I have just have to differentiate Vx, which is a constant. So if I differentiate, I'll get 0.
Yeah.
And A is Ax, x component plus y component, only j component is there. So that's why the answer is just j cap, and the value is 2.
Yeah.
So in the basics, we have a relation between y and x. Velocity is nothing but dx by dt, which is x component, and dy by dt. So differential thing with respect to
So
time.
we have to differentiate.
Yeah. Velocity is what? Dx by dt, no? And du by dt. And if z is there, dz by dt. That dz by dt will become vz. But there is just 2d. There is no z. Only x and y are there. Okay, and then he has given Vx is constant. So if I differentiate Vx, I'll get 0. So Ax is derivative of Vx with respect to time, which is 0. Question 8 is done.
Yeah. We have to do. Alpha angle 60 there again. A to left is 10 meter per seconds. A value 10 meter per seconds and alpha is given. Velocity of B. Just you have to use tan theta formula, I think so.
No. What is constant in this question? When the rod is sliding, what is constant? The length of the rod. Okay, you try it. Get the
Root
answer.
3 into 10, 17.3.
Check the answer.
Second. Seventh one is 4. The eighth one is 3. 3.
So what is when the rod is sliding, the variables are alpha, right? Alpha will change. The thing which is not changing is the length of the rod. Let me call it
U
L.
cos theta.
So if the length of the rod is L,
10 into
and let
cos
the x
60 is
coordinate
1
of
by
this
2.
point be x.
5 into root 3, which is
And the y coordinate of point B be y. Okay, that means the distance from here to here is x. And this distance from here to here is y. So Pythagoras theorem is x square plus y square equal to n square. Now differentiate both the sides with respect to time. We'll get 2x, x
2x plus 2y plus 2y y dot.
y dot equal to 0 because L is constant.
Okay.
Okay, and x dot is
X
how?
dot equal to minus y dot, minus 2y dot.
No. X dot is velocity of A, point A, but minus sign. Because A is moving towards left. X dot is how x is increasing. So that is, as it moves towards the left, x is decreasing. So it's minus V. And y dot is
Minus
plus
VB.
V, plus VB.
VB. Because it's moving in the positive direction.
Yeah, because B is moving in the positive direction. So velocity of B is same as rate of increase of y. Velocity is same as how the rate of decrease of x. Okay, so from this I get the relation between x times VA equal to y times VB. Okay, so VA is given 10 and then so alpha is 60. That means y by x is tan alpha and tan 60 is root 3. So it's 10 by root 3, which is 10 by 3 root 3, which is 17.32 by